Okay, so the following represents the results of a test by 9 students. Okay, so these are test results here. Okay, so first things first, they want us to find the coefficient of variation, the range, the lower quartile, upper quartile, interquartile range, and semi-interquartile range. All right. So the coefficient of variation, as I said, it measures consistency of a data set. Okay. A low coefficient of variation, then your data is consistent. Okay, or stable. Okay. A high coefficient of variation, data is inconsistent or less stable. Then in the business world, okay, and this coefficient of variation is used to measure risk versus return. Okay, because the formula of the coefficient of variation is the standard deviation, okay, which I said measures risk in the financial world. Standard deviations measures risk over your mean. Okay, so for certain securities like shares, okay, you would want to see, okay, what is the risk of getting this share versus the return. Okay, so first things first, we need to get our mean, and then we need to get our standard deviation. So, colleagues, I believe we remember how to calculate these, right? Do we remember how to get the mean and standard deviation? Let's get our papers. Let's start with the mean first. All right. So for the mean, we just have to add the numbers. So 10 plus 30 plus 45 plus 48 plus 50 plus 60 plus 73 plus 88 plus 98. All right. So divided by since they told us there are 9 students, so the number of data values are 9 divided by 9. So anyone with a calculator, tell me what we get when we add the numerator. Let's get our calculators, we add. Okay. On our numerator, we're getting 502. 502. Are we getting that on the numerator? Mm-hmm. Was that a question? Or someone lifted their hand? All right, colleagues, are we all getting the same value? I've got 55.8. That's the average mark of the test, 55.8%. Okay. Well, that's the general performance by the students. Any questions before now we get our standard deviation? Okay, now we can get our standard deviation. So say 10, 30, 45. Actually, let me use Excel here for this one. Okay, so here we put our marks. We got 10, 30, 45, 48, 50, 60, 73, 88, 98. All right, then we put our mean here, 55.8. So remember, I'm going to use this one to get the standard deviation, this formula here. Okay, first we get our variance, then we get the square root. I'll use this one here. This is the one I'm using. Okay, so the mean, we just put it here. Yes. So remember, you have to subtract. So the max, I'll denote it as x. Then the mean as x bar. So remember, yeah, the first thing you need to do, you need to subtract each mark by the mean. Okay, so going to say 10 minus 55.8, get negative 45.8. Okay, 30 minus 55.8, negative 25.8. 45 minus 55.8, negative 10.8. 48 minus 55.8, negative 7.8. Okay, you just, each data value, you subtract it with the mean. Any questions? Okay, then the next thing we need to do, we need to square. We need to square. Okay, so this negative 45.8 squared, get that value. Negative 25.8, we square it, we get this value. Negative 10.8, we square it, we get that value. Okay, each of these values, okay, these are called the deviations. These x minus x bar, these are called the deviations. So you square each of the deviations, all right? All of them, you square them. Okay. Any questions so far? Remember, where you're not clear, ask. Okay. Because this course is not a funny course. Okay. Once you get confused, you start hating the course. But it's a very fundamental course for your programs. So are there any questions so far? If not, then now what we need to do, we need to total up. So we say we add all these values here. We total them up and we get 6,105.56. All right, yes. So we apply this formula here. We first get our variance, then we get the standard deviation. The good thing with statistics, these formulae, they're usually given to you in your exam, so you don't really need to master them. Okay, don't really need to master them. So here, this numerator here, we're saying sigma, this letter E means you just add up. Yeah, we're adding up all the deviations which we squared. All right, so this value we got 6,105.56. That is in our numerator. Divided by n, which is the number of data values, that is 9 minus 1. So we're going to say this 6,105.56 divided by 9, you get 678.3956. Okay. Divided by 8. 9 minus 1, that is 8. So 678.3956 divided by 8, we get 84.79. Okay. Now, colleagues, this is just our variance. Okay, the variance is just the standard deviation squared. Okay, so we need to get the standard deviation. This S2 represents variance. Okay, so now you want to get the value of S, so you square both sides. You get the square root of both sides. Okay, square root of S is S, then you say the square root of 84.79 . The square root of 84.799, get a standard deviation of 9. 9.2. Any questions? Okay, remember, colleagues, standard deviation is just how spread the data is from the mean. Okay, how spread out the data is from the mean. A low standard deviation, the data is not really far from the mean. High standard deviation, the data is very far from the mean. So a standard deviation of 9.2, we can consider it low. Okay, we can consider it low. Now, it's time to get our coefficient of variation. Okay, because they said coefficient of variation is your standard deviation over your mean. So our standard deviation is 9.2. Our coefficient of variation is usually is put in percentage form times 100%. Okay, then our mean 55.8. So say 9.2 divided by 55.8. We get 0.164 multiplied by 100%, 16.4%. That is our coefficient of variation, 16.4%. So this coefficient of variation, we can't say it's high, it's relatively low. Okay, so we can say our data is consistent and stable. Okay, it's relatively low. If you start getting coefficient of variations of 50% and above like that, those are the ones you can regard as high coefficients of variation. Okay, there your data can be more inconsistent or less stable. Any questions? Okay, we go to part 2. We need to get the range. So the range is just your highest value in your data set minus the lowest value in your data set. So if we bring our data set here, these test results, okay, our highest value is 98 minus lowest value 10. So we have a range of 88. Okay. So there is a wide distance between the highest value and the lowest value. Okay. Anytime they ask you to get the range, that's what you do. You just get the highest value in your data set minus the lowest value in your data set. Any questions before we go now to the lower quartile? Okay, so we're now going to the lower quartile, right? Remember, quartiles divide the data into 4 parts. Oops, let me get some, my bundles are done. Let me get some bundles. Colleagues, where was I kicked out from? Where was I kicked out from? I just remember I asked a question and I just said it was quiet. That's when I saw I was kicked out. Which point was I kicked out from? Madam Anne, where was I kicked out from? Or Mr. Dumase? At which point was I kicked out? Have I found what? Sorry, my after the standard deviation. Oh, I was kicked out for a long time. So even this part for coefficient of variation. Okay, so we go to the standard deviation here, 9.2. Now, coefficient of variation is your standard deviation over your mean times 100%. Our standard deviation, 9.2. Our mean, 55.8. 9.2 divided by 55.8, 0.61. Now, could you mute your mic, Mr. James? So 0.164 times 100%, we get a coefficient of variation of 16.4%. Okay, which is like it's a relatively low coefficient of variation. Once it's very low, it's relatively low. It's a low coefficient of variation. So our data is somehow stable or consistent. Okay, due to the low coefficient of variation. Okay, yes. Any questions before we go to the range and the quartiles? Okay, so now get our range. The range is just your highest value minus the lowest value. So if we come to our data set here, the highest value is 98, the lowest value is 10. Okay, so our range is 88. Okay, so we have a wide range here from the lowest to the smallest value. Any questions on the range? Okay, now we're going to our quartiles. So colleagues, quartiles just divide the data set into four equal parts. All right, it just divides the data set into four equal parts. Okay, so we've got our lower quartile and we've got our upper quartile, and you also have the median is like you can think of it as the middle quartile. Okay, the median is the since it's the midpoint. Okay, so we're going to start with our lower quartile. Okay, we look at our data set here. Okay. First, let me find the median first so that we start dividing this data into parts. Okay. Now in the exam, you don't need to get the median. Okay, I'm just doing this for your sake so that you understand this concept. Okay, so you can use this formula for the percentiles. Sometimes they might even ask you to find the percentiles in the data. Okay, so this formula for percentiles, you can also use it to locate the position of the upper and lower quartiles and the median. Okay, so I'll use this formula here. Now, since this data set is small, we can use the manual method. Okay, you use the manual method. You first start canceling out the numbers until you find the middle one. Then you look at the lower part, find the middle one, upper part, find the middle one. But I just want to show you how we can use this formula, because in your exam, when you're dealing with ungrouped data, you're going to have a lot of numbers. Okay, and doing the manual approach will be tedious. Okay, so first things first, let's locate the median. So our median, the median is the 50th percentile. Okay, 50th percentile. So means we use this formula n plus 1. N is 9, so we say 9 plus 1 multiplied by p. P is 50, since we're on the 50th percentile. All of this divided by 100. 9 plus 1 is 10. 10 times 50, that's 500. 500 divided by 100. Our median is on the 5th position. Okay. The median is located on the 5th position. So you come to your data set here. 1, 2, 3, 4, 5. So this is our median, the 5th position there. All right. So we've first split our data set into two equal parts, our lower part and the upper part. Okay. Now, after we've got our median, we want to get our lower quartile. So the lower quartile is the 25th percentile. Okay. The 25th percentile. Okay. So we use this formula for percentiles here. It's 9 plus 1 multiplied by 25, all of this over 100. 9 plus 1, that is 10. 10 times 25, that is 250. 250 divided by 100, 2.5. So our median is on the 2.5 position. Our lower quartile is on the 2.5 position. Okay. So you come to your data set here. This is our median. In our 2.5 position, so you say, come to our data set, 1, 2. So 2.5 is between 30 and 45. Okay. So we'll label this as Q1, our lower quartile. Okay. It's on the 2.5 position, so you count here 1, 2, so it's between 30 and 25. So we need to add them. 30 plus 45, so that we get and divide by 2, so we get our value. So we're going to say 30 plus 45 divided by 2, that is 75. 75 divided by 2, that is 35.5. All right. So our lower quartile is 35.5. So what this is telling us is that 25% of the data values are below 35.5. Okay? 25% of the data values are below 35.5. Okay? So if you got a 36 in this test, you did better than 25% of the class. Any questions before we now go to our upper quarter? Our upper quartile is on the 75th percentile. Right, so you get here, you're going to say 9 plus 1 times 75. All of this divided by 100. 9 plus 1, that is 10. 10 times 75, 750. 750 divided by 100. It's on the 7.5 position. So if we come to our data set here, we count 1, 2, 3, 4, 5, 6, 7. So 7.5 is between 73 and 88. Okay, between 73 and 88. So we're going to say Q3. Okay, upper quarter is Q3. Okay, the median is Q2. Remember this, colleagues, okay? Q1, lower quarter. Q2, median. Q3, upper quarter. So we're going to say 73 plus 88 divided by 2. 80.5. Oh, what is that? 161 divided by 2, that is 80.5. So 75% of the data or the test scores .5. Any questions? This is the upper quarter. Okay. But as I said, when it's a small data set like this, you can use the manual method. Okay. I just wanted to illustrate this formula. Okay. Okay. So we now need to find the interquartile range. Okay. The interquartile range is just your upper quartile Q3 minus Q1, the lower quarter. Okay, so our upper quarter was 80.5 minus 35.5. 80.5 minus 35.5, we get 45. Okay, that is our interquartile range. Okay, then the next part, the semi-interquartile range. So it's just the same here, it's only that we're dividing this quartile range by 2. Okay, the semi-interquartile range, just the interquartile range divided by 2. So we already got 45 here. Upper quartile minus lower quartile, already got 45. Half of 45 you get 22.5. Any question? Yes. Then if they're ever told to draw a box and whisker plot, okay, if you're ever told to draw a box and whisker plot, the way we've done it here, okay, find your upper quarter, lower quartile, and your median. You draw this box here, right? Lower quartile was 35.5, median is 50, upper quartile is 80.5. Okay, then you put here your minimum value, which is 10, and then here your maximum value is 98. Okay, so if they had to ask you, draw a box and whisk plot for this, for your data set, okay, just get your minimum, your maximum, lower quartile, median, and upper quartile. Then have you seen the way I've drawn this box, this shape here? That's how your box and whisk plot should be. Questions and queries.